Hello and welcome to another demo. The purpose of this demo is to actually understand how we can use technology called RAID, which stands for redundant array of, depending on which documentation you look at, they might either call it inexpensive or independent disk RAID. So we will in this demo try to explore how we can use RAID in Linux. So why do we want to do that? Because this can fail for whatever reasons, and that can have a disastrous consequences for our data. And that's why we need a way to, uh, uh, a solution that will help us that if one disk goes down, that it doesn't actually take down or, you know, make our data inaccessible. And one thing to bear in mind, RAID is not a backup. Backup is something that you store and restore again. But RAID is basically meant for to help us with in the event that a disk is um, in the event that the disk goes down, whether it's one or two, depending on the kind of level, RAID level that we choose. All right. So this is a technology that will give us the possibility, for example, for you know to withstand a failure of one or two disks, depending on the configuration that we choose or the level of the rate level that we choose. All right. But suppose that we have a Linux system with some disks attached to it, and we want to find out, if what are the disks that are attached to it. We've done this in the partitioning demo. We'll do the similar thing. We will use the fdisk command with the -l to list to see what disk that we have on our system. All right. The command, of course, requires root privileges. That's why you need to use root. That's why we need to use the sudo if we're not already in the root user. So here we see that we have, once we issued it, there's a lot of, these are not actual disk, these are virtual disks, so we don't have to look at that. But this is a disk, as we've seen in the partitioning demo, which has two partitions. We also have, these are the disks, SDB, SDC, SDD, and SDE. Those are the ones that we're going to use for this demo. All right, so we see that the system has five disks: SDA, SDB, SDC, SDD, and SDE. We also see that the device SDA already contains two partitions. That's the one that's being used by the operating system. All right. Um, a disk that does not contain a partition, as we've seen, will basically, you know, have some metadata, but it will not have any partitions on it. So let's suppose that we want to use the disk that are not partitioned for the purpose of RAID. Uh, we are assuming that we have the necessary software, but in the lab machines, the package which is called mdadd will be installed, and that's the software that we need to be able to use and manage RAID. But if it's not installed on your system, then it's just, because we're using Ubuntu, it's just as easy as sudo apt install -y mdadd. All right, we can once the software is there, we can of course use the disk directly without doing any partitions on the disk. The empty disk that we've shown, the SDB and SDC and SDD, but it's better to partition it to prepare it for RAID. Basically, we can partition it and say this will be used by RAID. All right. In the previous demo or assignment, we did this manually because we had to make several partitions within one disk. But in this demo, we don't need to do that. We'll rather use one command to partition the whole disk. All right, and say that we want it to be type FD, which is Linux RAID Auto. All right, but we can of course script this and make it easy for us, but we will do it line by line just to show it how it's done. Using instead of using fdisk, we will use another tool or another command called sfdisk. Okay, you see this is the first disk. We have already partitioned it, and it tells us this is the partition, and it writes it to the file because we're done with the partitioning. All right, let's do it again for the other one, for the other three, for the other, the other three disks that were ready. So we've done all of those as SDC, SDD, SDC here, SDD there, and SDE here. We all of them are partitioned as Linux RAID auto detect. All right. Okay. Now let's check with fsdisk, or sfdisk. It doesn't really matter, but which how the disks that we had before are partitioned. We see that. Let's go up. This is the command we issued. We see SDA that was partitioned already. We see now SDB has one partition, which is Linux RAID. SDC has one partition, which is Linux RAID, and so on and so on. All right, great. We have the disks, and each one of them has one partition for the whole disk of type Linux RAID auto discovery. Yeah? We can now proceed to use mdadd to actually configure those disks. But before we do that, we need to decide what sort of a level that we need. Uh, Depending on the number of disks that we have in this demo, we will use RAID level 5 because we have 4 disks. RAID level 5 requires only 3 disks actually, but the fourth disk can be a hot spare. But in this demo, we will not use any hot spare. We will just create the RAID 5 on the 3 disks. Um, this, of course, is dictated by the amount of disk that we have, whether we want it to have to withstand 1 disk or 2 disks. RAID 5 will only withstand 1 disk, while RAID 6 will be able to withstand 2 disk failures. All right. We will in this demo, as I said, create a level RAID level 5. Done. It has created. The command creates on top of that. Now uh, we can check and display the information of the device. We see great with this command mdadd -d and the RAID device that was created. It tells us a little bit of metadata information and the disks that are part of the RAID. All right, good. It was created. Nice. Another command that we can use is, of course, the cut proc mdstat. We can see that it has already done. Usually we'll see the progress, but it tells us that all the disks are used. MD1 active RAID 5 on these partitions. All right, good. Now that we have configured the RAID device, it's also a good idea to save the configuration into a configuration file. Let's do that. Great. And it's also a good idea to update the initial RAM file system. This is to help the operating system to know so that when the next time it boots, it doesn't assign the RAID to an arbitrary, random name, but that it used the name that we gave to it, namely MD1. Okay. Now that it's updated, we're done. So far, so good. Once we have the RAID device, what can we do with? Well, because the RAID device will look like a disk, one disk. All those 3 disks will look like one disk to the operating system. and we can, you know, create logical value management. That's another way of doing partitions logically. We can create file system on it, we can partition it, we can do whatever we want to it. So it becomes like one disk, and the operating system will take care of the rest behind the scenes of storing the data on the right device, and having a redundancy, and spreading the data on the different devices, and having so what's called a parity check, so that if one disk goes down, since we're using RAID level 5, then the data will not be lost. All right, done. That concludes this demo of creating RAID, especially RAID level 5. Bye bye.